Welcome you all to my YouTube channel. Today we are here to discuss about a topic which is optics. Optics is a branch of physics which deals with the study of light. Means in this video we are going to read about light. Light having different properties. Light is a form of energy which gives us the sensation of vision, because of which we are able to see our surrounding, we are able to visualize our surrounding. Light having some properties. First one, reflection. Then next, what we read in class 9. Next is the refraction, what we are going to read here. Then dispersion, scattering, and interference. So let us start. Today's topic is the refraction of light. This is the part 1, and I'll come very soon with part 2 and also part 3 of this refraction. So let us start the refraction. Whenever light rays pass from one transparent medium to another, what we can say the transparent medium? Transparent medium means which allow almost all light to pass from one side to another, or which will not absorb any amount of light. That is a transparent medium. When it will pass from one transparent medium to another, let's take the example here, air and water. Air, we know speed of light is 3 into 10 to the power 8 meter per second, which is maximum. Means in water is less. Whenever light is coming from a medium with more speed to less speed, then here the will get the change in direction. This is the original direction, which is called the incident ray. From the source, it will hit to the boundary. The boundary or the separation of air and water. So some part of light will reflect back, which is called reflection of light, or the light is called the reflected ray. And maximum part will come into the second medium. So that bending of light, this is the actual path of light. But here when we look to the water, the light rays slightly bend. That's what you can say, the refraction. And the angle formed between incident ray and normal is called angle of incidence. The angle between normal and refracted ray is called angle of refraction. Here it is not a reflection, it is a refraction. When the light is passing from one transparent medium to another, because the change in speed, light will bend, so we'll get the refraction. This refraction we are going to discuss in this video. So, what we can say the refraction. Refraction is the bending or change in direction of light when it passes from one transparent medium to another. That can be from air to water, water to glass, glass to diamond, or glass to water. So whenever light will bend, why it will bend? Why this refraction occur? This refraction occur due to the change in speed of light, because light is an electromagnetic wave which is having different speed in different medium. So the bending of light is due to the difference in speed. The more the light slow down, the more we'll get the refraction. Now, next thing to look here. The phenomenon of refraction generalized in three ways. Means either light rays can go from a medium with more, where it is having more speed to less speed, or it can go from a medium from less speed to more speed. More to less it can go, less to more it can come, or it will pass in the same medium, or it can pass in a straight line. So when a light rays pass from one transparent medium, here you can see two words. One word is the rarer, R-A-R-E-R, rarer, optically rarer. Rarer means when the medium in which speed of light is more. DE and AC are denser. Thus, the medium in which speed of light is less. So, when a light is passing from a medium with more speed to less speed, or you can take air to glass, air to water, air to diamond, because in air it is a maximum speed. So, it is bending towards the normal. Means here we'll get angle of incidence is more than angle of refraction. Means this angle is more, whereas angle of refraction is less. So that difference between them is the angle of deviation. Angle of deviation. Angle of deviation denoted by a Greek letter delta. We got a triangle symbol delta for small change. This is the angle of deviation delta. And whenever light is passing from a denser medium, denser means where the speed of light is less, to a rarer medium where the speed of light is more, we'll get angle of refraction. The angle between refracted ray and normal is more in compared to angle of incidence, the angle between incident ray and normal. So that difference, now what we'll get? Angle of refraction minus angle of incidence, we'll get the angle of deviation. Means if the light is passing from rarer to denser, means more speed to less speed, it bends towards the normal. If it is going from denser to rarer, less speed to more speed, then it go away from normal. And third one, if it will pass straight. When the light will pass straight, that time angle of incidence is 0 degree, because the angle between normal and incident is angle of incidence. So that time light will not deviate, it will go fully straight. So that is the reason that whenever I look into a glass apparatus, we have to look straight to avoid the parallax error. Next one, the laws of, like we got laws of reflection. Here in refraction also, light will obey two laws. First one, the incident ray, refracted ray, and the normal, where these all lines or all these ray where will get at the point of incidence, must lie in the same plane. Means in one plane only will get incident ray, normal, and refracted ray. And next one, here little bit change from law of reflection to when the light is passing from one transparent medium to another. Sine, SIN sine, that is trigonometric expression, SIN sine. Sine of angle of incidence to sine of angle of refraction is always constant. That means sine I by sine R. I angle of incidence, R angle of refraction. Sine I by sine R always remain constant. And this law or this constant is known as refractive index of the medium. Means sin A by sin R is a constant, which is refractive index. And the second law given by a scientist and with whose name this law also known as the Snell's Law is the Wilbur Snellius scientist who has given this law according to his name. This is known as the Snell's Law. So when it comes to mathematical expression of Snell's law, the second law of diffraction, we'll get here the sin I by sin R is equal to constant, which is refractive index. And here you can see another Greek letter used, which is mu. This is the letter mu. Mu is used for refractive index. Then welcome to the unit of refractive index. We got a ratio sin I by sin R, and also we'll get different relation. We'll get different ratio for this refractive index. So refractive index is a ratio, and we know ratio is a comparison. Ratio having no unit. So refractive index also having no unit. Only it will say us, or it will by this we'll able to know how much the speed of light is more or less in a given medium. So refractive index having no unit. Refractive index of a medium. Refractive index of a medium, but we got sin I by sin R. But when the light is passing from one transparent medium to another, with the speed, if we'll compare the speed of light in that particular medium with speed of light in air, we'll get refractive index. Refractive index can be defined as the speed of light in vacuum or air to the speed of light in a specific medium. Means speed of light in air or vacuum, which is 3 into 10 to the power 8, or which is denoted by letter C. Here you can see letter C for speed of light in air or vacuum by speed of light in a medium V means C by V will get the refractive index, which is denoted by letter mu, or big letter mu. Means from refractive index, we'll able to know how much time the speed of light in that medium is less in compared to speed of light in air. Means here you can say the ratio between speed of light in air or vacuum to the speed of light in a given medium is the refractive index. So here we read before that optically rare or optically denser. What that optical means? Optical density. The term optical density actually means the tendency, the property of a medium to absorb electromagnetic energy. Electromagnetic wave means which does not affected by electric or magnetic field, which does not require any medium to propagate. So that is the electromagnetic wave. So optical density of a medium is more, means that is called optically tensor, where the speed of light is less. If the speed of light is more, that is optically rarer, means optical density is less. Optical density more, optically denser. Optical density low means optical density is less. When we will look here in this relation, speed of light by speed of light in vacuum by speed of light in a medium, refractive index, that means speed of light is more, refractive index less. If refractive index more, speed of light less. When a ray of light is passing from one transparent medium to another, its frequency remains constant. And we know wave velocity equal to wavelength into frequency. So we'll get the relation here. C by V means F into F is the frequency to wavelength by frequency to wavelength in that medium. So we'll get our refractive index, wavelength of light in vacuum by wavelength of light in a medium. So when we'll come to the example of this refractive index. Refractive index of a medium, if it is given, what we'll understand from that. Let to look here. At the speed of light in air or vacuum is maximum. Means there is no other medium where where the speed of light can be more other than air or vacuum. Means absolute refractive index cannot be less than 1. Absolute refractive index means speed of light in air or vacuum by speed of light in that given medium. Another one, relative refractive index. When a ray of light is passing from glass to water, to medium, not air, glass to water. So speed of light in so speed of light in so speed of light in glass by speed of light in water will get the refractive index. That is relative refractive index. Absolute refractive index means speed of light in air by speed of light in a given medium. That may be glass, that may be water, that may be diamond, or any other medium. Next one. Here you can see one more thing. Refractive index of diamond 2.42. What will mean by this statement? That means speed of light in diamond is 2.42 times less in compared to speed of light in air. Or in other term, we can say speed of light in air is 2.42 times more in compared to speed of light in diamond. We'll take another example here. Refractive index of water 1.33. That means speed of light in water is 1.33 times less than the speed of light in air, or you can say speed of light in air is 1.33 times more in compared to speed of light in water. Means from refractive index we'll able to know the speed is more or less, or how much time more or how much time less. Here, on which factor this refractive index depends. First one, refractive index is depending upon nature of a medium. Means less the speed of light in compared to how much less the speed of light in compared to air, more the refractive index, because refractive index equal to C by V. Less the speed, more the refractive index, more the speed, less the refractive index. refractive index is depending upon the speed of light or depending upon the nature of the medium. Second one, it depends upon the temperature. With the increase in temperature, speed of light increase. So with the increase in speed, refractive index decrease. That means temperature and refractive index inversely proportional to each other. Next one, it will come to the color or wavelength. Speed of all the visible color, VIBGYOR, all these color are having same speed in air and vacuum. But when they are going from air to any other medium, their speed change. Red color is having maximum speed, so minimum refractive index. Violet color is having minimum speed, so maximum refractive index. So all the color are having different refractive index in other medium. We will come to the next part here. In this part, if we look some summary of all these things what we read. If we look first one, refractive index of optically rarer medium is less and denser medium is high. Means speed of light in rarer medium is more, denser medium is less. Refractive index of denser medium with respect to rarer medium is more than 1 and rarer medium to denser medium is less than 1. So and for air and vacuum it is 1 refractive index. Refractive, when refraction occurs, the velocity and wavelength change but frequency remain constant. So another one, the principle of reversibility. Reversibility means when the ray of light will pass from medium 1 to medium 2 or medium A to medium B, when it will hit to a reflecting surface, return back or we'll get the reflection of light. So when you return back, it will follow the same path but in opposite direction. That is called path of reversibility, a principle of reversibility. When the ray of light is going now from A to B medium, so refractive index of B with respect to A, which is sin I by sin R. Here I is the angle of incidence, R is the angle of refraction. Second law of refraction. So when the light is reverse now this ray is the incident ray, and after refraction we'll get the second ray. Means when the ray of light is going now from B to A, sin I place we have to take R and R place we have to take I because the light is passing from B medium to the A medium. So here we got sin R by sin I. That means refractive index of B with respect to A equal to 1 by refractive index of A with respect to B. When the ray of light suffer reflection, it takes or path will reverse. It will go or come back, return in the same path but in opposite direction. So this phenomenon, natural consequences of reversibility will get when the position of image and object change. So this one, the principle of reversibility. Another one, when the ray of light will pass, now when the light rays will pass through a rectangular glass block. What we can say the rectangular glass block. A glass block means a cuboid made of glass, as glass is a transparent medium, so it will allow the light rays to pass from one side to another. So whenever we'll keep a glass block and light rays will pass from one side to another, what are the changes we'll get? That's what we are going to elaborate here or we are going to discuss here. So whenever light rays now is passing from air, here it is the air, and A, B, C, D, this one the glass block. And next after passing the glass, again it will come to air. Means both side air, in the middle we are having the glass. A denser medium where the speed of light is less. Now, the ray of light incident from a source to the boundary of air and glass. When we pass now from air to glass, refraction occurs. It is the first refraction. Your angle of incidence I and angle of refraction R. Now this light rays will pass inside the glass because it is going the same medium. Its speed remain constant, path will not change. This is the uh, line. This is the path followed by this light. Now light come to the second boundary between glass and air. Inside the glass, the speed is less and in air speed is more. Now it is going from denser to rarer medium. So light will go away from normal. Fast diffraction case, what we got? Air to glass. So it was coming toward the normal. But now it is from glass to air. So it is going away from normal. It will not keep any glass block in the middle. Then light will come in this way. This dotted line is the actual path of incident light. But because of two refraction, light is going another line or little bit displaced from its original path. And fast angle formed between incident ray and normal. This angle is angle of incidence. So when this light rays is passing now from air to glass, here you can see this is the incident ray. Angle between normal and incident ray is the angle of incidence. It will come to the glass, means air to glass coming towards the normal. A refracted ray and normal making the angle called angle of refraction. This refracted ray now when it will come to the second boundary and it will go from glass to air, when it is going away from normal, this ray is called the emergent ray. An angle between emergent ray and normal is called angle of emergence. Because in rectangular glass block, these two surfaces or two refracting surfaces are parallel to each other. So angle of incidence is always equal to angle of emergence. And this lateral displacement, here you can see another diagram where the perpendicular distance between emergent ray and incident ray is known as the lateral displacement. And this lateral displacement again depends upon different factor. That to discuss on which factor this lateral displacement depends. Lateral displacement depends upon different factors. Means when the light rays is passing from one medium to another, the perpendicular distance between the actual path of incident ray and emergent ray is called lateral displacement. This lateral displacement first depends on the thickness of medium. Means more the thickness, more the lateral displacement. Means if you are taking the thicker glass block, the lateral displacement you will get more. If you are taking thinner glass block, you will get lateral displacement less. Second one, it depends upon angle of incidence. Means more the angle of incidence, more the lateral displacement. Less the angle of incidence, less the lateral displacement. And also depending upon the refractive index. Refractive index of a medium is more, lateral displacement also more. As we have discussed earlier, violet is having refractive index maximum and speed of light minimum. Red is having speed of light maximum, refractive index minimum. So lateral displacement is more for violet and less for red. Means lateral displacement is depending upon thickness, angle of incidence and refractive index. Now, when this light rays will pass through a thick glass block or if the thickness of mirror is more, mirror where one side is polished and other side we have given a coating of different layer, mercury oxide, you can give a silver oxide. When we are taking a thicker mirror, why the second image is always brightest, that we are going to discuss here. Second image time, when we will take a thick mirror, silver at the back, a large number of image can be obtained, and in that thicker mirror, the second image is always brightest. Why the second image is brightest? In case of fast, let us take the fast image case. In case of fast image, because we read in the first of this video, some part of light is reflect back and maximum part will suffer the refraction. That because of the reflection, a image form. Because the intensity of light is not that much higher, so we'll not able to get a clear image. But in case of second image, light will suffer the maximum refraction and reflection. Means maximum amount of light can be refracted and reflected back. Because of which the second image always brightest and rest images due to the multiple reflection inside the mirror, some amount of light is absorbed, the intensity gradually decreases and will not able to see the image clearly or that image brightness is not that much high. In second image, always brightest because the lightest suffer maximum refraction and reflection. So this is about the fundamental concept of refraction. When the light rays will pass through a triangular glass prism, what will get? When the light rays pass from one transparent medium to another, that time height of the object, how much change, increase or decrease, that we are going to discuss in our second part. So to get more videos of physics, what you have to do?